Okay, so this section just asks how many solutions, not for the actual solutions. So we won't need the full quadratic formula, but I'll write it just for reference. Okay, so when we only need to know how many solutions, we can use what's called the discriminant. Okay, so b squared minus 4ac, which is exactly what's underneath the radical in the full quadratic formula, right? So there's a reason that this is that. So looking at problem 1, so first of all, in order to use the quadratic formula or the discriminant, you need one side to equal 0. So in this case, we've already got that. Okay, so we can identify the a value, which is the coefficient of the x squared, the b value, which is the coefficient of the x, and the c value, which is the constant. So applying that to the discriminant, b squared is 4 squared, minus 4 times a, which is 4, times c, which is 1. So 4 squared is 16, minus 4 times 4 is 16, times 1 is still negative 16. Okay, so for problem 1, the discriminant is 0. Okay, so what does that mean? It means if we did the full quadratic formula, this whole radical would be 0. So then whether you add 0 or subtract 0, you get the same answer either way. So there is only going to be one real solution. Right? Whenever the discriminant is 0, that means there is one real solution. Because you add and subtract 0, it's the same thing. Okay, let's try problem 3. Again, we already have a 0. But this one's tricky because these first two terms, they need to be combined. Right? This is not an x to the first power, it's an x squared. So 1x squared minus 8x squared is negative 7x squared. And I can put in a placeholder plus 0x to the first power minus 9, right? Because that allows me to more easily identify my a, b, and c. Okay, so now I'm ready to do the discriminant. B squared minus 4ac becomes 0 squared minus 4 times negative 7 times negative 9. Okay, so this is 0 minus 252, which is negative 252. Okay, so this means that if we did the full quadratic formula, this part would become square root of negative 252. And any square root of a negative is not real. So any negative discriminant, whether negative 1, negative 1 million, always means no real solution or no real roots. Okay, problem 3. So it may help to rewrite this first term. Dividing by 2 is the same as multiplying by a half. So a is a half, b is negative 1, right, negative 1x, and c is positive 1/4. So substitute into your discriminant. Make sure you use parentheses if you're using a calculator. The whole negative 1 gets squared. Negative 2 times a fourth is negative a half. Okay, so the discriminant is a half. So over here it'd be square root of a half. So whether you add or subtract the square root of a half makes a difference, right? Plus a value is different from minus a value if that value is not 0. So any positive discriminant, whether a half, 50, 10 million, anything that's not 0 and not negative, any positive discriminant, means you'll have two different answers, one from adding, one from subtracting. Okay, for 7, again, we can make this 1/2 x squared. So a is a half, b is negative radical 2, c is 1. Doing our discriminant, again, put your parentheses, b squared minus 4ac. So negative radical 2 all squared. Negative times a negative is a positive, and radical 2 times radical 2 is regular 2. Negative 4 times a half is negative 2, times 1 is still negative 2. Okay, so our discriminant is 0, which again means in the full quadratic formula, you would be adding or subtracting 0, which is the same. So whether you add or subtract, you get the same answer. So one real solution. Okay, moving on. So this time we do want the actual solutions, not just how many. So we'll need to apply the full quadratic formula. Okay, so before using the quadratic formula, we need to set it equal to 0. If you remember the way we found the quadratic formula, we completed the square when it equaled 0. So I choose to keep the x squared term positive. So I'm going to subtract these terms over. Okay, you would still get the exact same answer if you subtracted 6x squared from both sides. Your a, b, and c would be different, but the final result would be the same. Okay, so now we can substitute into the quadratic formula. Negative b, or sorry, don't forget your x equals. So negative b becomes negative 10, plus or minus the square root of b squared, so negative 10 squared. Again, keep your parentheses. Minus 4 times a, which is 6, times c, which is negative 4. And that's all over a denominator of 2 times a, which was 6. Okay, so let's simplify what we can. Opposite of negative 10 is positive 10, plus or minus the square root of negative 10 squared is positive 100. Negative 4 times negative 4 times 6 is negative 24, times negative 4 is now positive 96. All over 2 times 6, which is 12. Okay, so 196 is a perfect square. 14 times 14 is 196. So we can do this, right? So the square root goes away because you used it to change the 196 into 14. So whenever you have the radical go away, you do need to do both the plus and the minus. You can't just leave it like this. So one version is x could be 10 plus 14 all over 12. The other is x could be 10 minus 14 all over 12. So this plus sign becomes 24 over 12, or 2. This one becomes negative 4 over 12, or negative 1/3. Okay, so our answers are 2 and negative 1/3 for problem 9. Okay, looking at problem 11, again, we need everything on the same side. Okay, so for me, my a value is 4, my b value is 1, my c is negative 4. Okay, apply the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, sorry, a is 4. Okay, so negative 1 plus or minus 1 squared is 1. Negative 4 times 4 is 16, times negative 4 is positive 65. Oh, sorry, that's 64. Negative 4 times 4 is 16, and then times 4 is 64. Okay, so then 1 plus 64 is 65. All right, so in this case, we do not have anything we can take out of this radical. 65 is 13 times 5, both of which are prime. So here you can leave your final answer looking like this, because you can't add or subtract because non-radicals and radicals cannot be combined. So this would be your final answer. Okay, 13, again, let's get everything to the same side. Right, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, let's simplify what we can. 14 squared is 196. Negative 4 times 8 is negative 32. Times 3 is negative 96. Okay, so 100 is a perfect square. It is 10 squared. So x equals negative 14 plus or minus 10 over 16. So again, you would not leave this as your final answer. Because the radical went away, we can go ahead and split it up. Right, one version's with the plus sign, the other version's with the minus sign. Okay, so negative 14 plus 10 would be negative 4 over 16, which is negative 1/4. And then negative 14 minus 10 or plus negative 10 is negative 24 over 16 or negative 3 over 2. Okay, so it looks like our two answers are x could equal negative 1/4 or x could equal negative 3/2. Okay, and finally we've got a word problem. So we want the height of the ball to be 1 meter, and it says the height is h. So this h needs to equal 1. Okay, so the quadratic formula again requires one side to equal 0. So let's subtract 1 from both sides. Okay, so our a value is negative 4.9, our b value is negative 5, and our c value is positive 1. Okay, so the quadratic formula, the variable is t this time. So negative b, so negative negative 5, plus or minus the square root of b squared minus 4 times a times c, all over 2a. Okay, so for this one, we would probably use a calculator. So let's see, fraction, we got opposite of negative 5, plus or minus, I'll do the plus first. Okay, so plus first, plus the square root of quantity negative 5 squared minus 4 times a, which is negative 4.9, times c, which is 1, all over a denominator of 2 times a, which was negative 4.9. Okay, so again, this is the plus version. Oops, let's see what I messed up. I forgot to close out my parentheses. Okay, so the plus version leads to a t value of negative 1.19 approximately, and the units are not given, but I think we can assume they're seconds. Okay, and then if instead for the plus minus we choose the minus, so I'll go back up here and change the plus sign to a minus. I get approximately 0.17. Okay, so now we need to take into account the real life situation, right, because this is a word problem. A negative time does not make sense, right? That would be before they kick the ball, so how could the ball already be at the correct height? So because it's a word problem, we can get rid of that answer, and the only solution is 0.17.